So I have done some backend CLI implementation using Perl and ClickHouse to convert the net flows into a ClickHouse database. So I first ran a native uh, implementation similar to what we have right now in OPFlow. And again, you see the same problem which we have with current OPFlow. So as the database size grows, the queries get pathetically slow. Even minutes to run some queries. So that happens after around 30-40 GB of flow. So simply replacing the our database with ClickHouse is not going to help much. So we need to implement more things to make this work give some better performance. So again, I implemented something before in Python and this what do we call it? I forgot. Perquit. So that basically bypass all the performance issues because we are storing the data in a way that uh, it implement multiple logics. But yeah, when the query come, you basically uh, get a lot of pre-processed data. So I have moved some part of same implementation using Perl and ClickHouse. So I first thought of Python, but then I don't know. We are biased toward Perl. So yeah, it's be Perl and ClickHouse. So this is just a backend implementation with only few counters. So I have covered packet, bytes, and flow. To get a full-fledged implementation, we will have to implement all the counters which are present in NetFlow packets. But yeah, that should be just incremental once we have all this base created. So that will be just adding one or two parameter here and there. Anyways, the infrastructure I have completed a lot. So the requirement for running this backend, you can run it on native any uh, uh, server right now itself without OPFlow. So backend CLI implementation is complete and you can run all your top apps query using just this. So we can take a big database, whatever our use case are, just install ClickHouse, server and client both, and assign the passwords correctly in a ClickHouse. Then we have to install nfdump 1.7.7. It has some additional uh, APIs to fetch applications, ASNs, etc. So yeah, that need to be installed. And then this is a my daemon, which basically is a Perl implementation which configure all the database, read data from nfdump, put it here, and it implements a lot of things. So once you have this running as a daemon service, it will basically convert all your nfdump files and put it into the ClickHouse database. Then you have a query function, and with this query you can query the top apps, top protos, conversations, top SRs, IPs. Similarly, you can implement. We can implement a lot more things here. So yeah, so that's the overall logic. So on this server, I have implemented this same. So you connect with ClickHouse with a password. So if you see databases, yeah, you will see multiple database here. And if you go into, let's say, one database, so here there is a whole mess of databases created which are of multiple frequency: monthly, hourly, daily, 15 minutes, 5 minutes. Yeah, so there are a lot of these, and these are all interconnected via material age views and views. So these are all interconnected and jumbled with one another, and these all are created by the daemon we saw earlier. Okay, so just so yeah, so this daemon which we created, this basically all does the heavy lifting related to database. So once we have database created and nfdump files are nfdump logs are coming, so this daemon basically reads all these, fetch the important data and start feeding into these tables. This all happens in a background, so and it can run in parallel. So if you have a lot of data, you can run these in parallel. I right now I'm running in these in parallel, so these all are processed in parallel threads, and no two functionality are interrelated, so all can work on more with more threads, more applications. So nothing gonna cause a bottleneck. If you have more data, you can run more threads. So and these are not in a performance path, so none of this affect one another. So yeah, so so once you have database fed with all the data, you can query. For example, let's say I want to query, yeah, here it is. So this is a simplest query. So again, these can be are reachable via APIs if you want. If you want to integrate this system with our current OP flow, just use this Perl, fetch the data and feed it into our current system, current API, top application, top source IP. So this is a simplest query. So here we are querying source IP, okay, and we are fetching last 1 hour data. So if we will do that, so now again, once we, so yeah, the logic is here. So if you fetch like 1 hour data, so it is not going to fetch from a single table. So it basically tries to determine from this period what is the best frequency, best tables which we can look into, and it combines all the data from these multiple tables and create a full-fledged total from multiple tables. It doesn't, so like for 1 hour it has fetched some data from this 5-minute table, from 15-minute, 5-minute, and it combines all these data to get the total. So if you do a like 1 day, okay, so it is fetching some data from 15-minute table, 1 hour table, 15-minute, okay. So similarly, if you do for 7 days, okay, so it is fetching some data from 1 day tables, some from 1 hour, 15-minute table, 5 minutes. So it fetches from multiple tables from where the data is available. So again, it does a performance optimization. So rather than fetching from coarse granularity, finer granularity, it fetch coarser granularity when you are not asking for history points, just the total. But if you want points also, then it does the opposite algo. It goes in, it tries to fetch maximum data from finer table. So yeah, so that's how we fetch data. Again, here you can apply filters also. For example, I want to filter based on source IP, which let's say end with 2. So what I've done, yeah, so all these IP which end with 2, it is fetching. So you can apply different filter. I want to search only single IP, let's say 9.9.2. So I'll get this data. Okay, so I can fetch history points also, like what points are, so that we can plot a line graph. So history equal to 2. So yeah, it is pretty fast, 2 seconds it fetched all this data. So yeah, so for all these different IPs, it fetch history points, like this was at 55 1 1 5. So yeah, so it is fetching every 5 minutes data and the flows at that particular time, so that you can plot a uh, graph out of these points. Okay, so or you can apply filters like whose flows are less than 1000. Okay, yeah, so you will get all the flows whose are which are less than 1000. And here also you can apply multiple filter, minus my filter equal to, let's say, whose IP has a 88 in it. Okay, so yeah. So these are the IPs whose are 88 and flows less than. So this way you can do all sort of filtering. You can assign, order it in ascending order. Okay, and whatever. Okay, something wrong with it. It should work. Why order work? Okay, order. It's not order, it's direction. Order is the order field. Direction. Yeah, so here the flows are in ascending order, starting from 8 7, lowest one at the start, or you can do it in descending with the highest at the top. Okay, and you can define the order field also, on the basis of which it will, if I want to use byte, I can do ibyte. Okay, so similar to these flows, this source IP, you can do query on conversations also. So conversation, okay, cli.pl. Okay, so this will give me last 1 hour conversation ordered on flows. Okay, so this is my from source to destination, and which protocol and which router it is, from where that data is coming. Okay, so yeah, so now you can do it for 7 days, which should be slow, but yeah, it is not. So it is fetching data from a huge table and still trying to at the maximum. Again, it achieves this 7 day by going through a combined 1 day. So 5 minutes will have lots of entries, so it just try to get this maximum data from 1 day. Whatever doesn't fit in that day, it takes from hour, 15 minutes, 5 minutes. So yeah, it apply all that logic. Again, you can filter here, like I want to see only protocol 17 packets, so I'll get all the conversation with protocol this 17, or from router, let's say 51, just 51, not the others. So yeah, I can check all the conversation related to coming from 51. So we can add our interface etc also, so that you can check on interfaces. all the detail. So similarly, we have seen source IP, destination, source IP, and what conversation. So yeah, so we can check protocols also. Okay, so which are the top protocols here? So yeah, we have this TCP, UDP, others. So yeah, so you can see history point, history equal to 1. So you can check history points. This was running on second entire day, the total number of flows were there. On third, it was there. From third, after 20 hours, it was this. From 20 15 minutes points here now, and that way this generate all the data. Then you can query the applications. Okay, so application is named as SICSN CLI. So yeah, so you can see these are my top application: Google, Amazon, Microsoft, Facebook, Apple. So these are my top applications here. So I can filter on these application, like I want to see Apple star. Okay, and it doesn't work because I didn't put here this. Okay, so or I can do a star all starting with A, so I get Amazon, Apple, Akamanai, Alibaba, and yeah, so I can fetch application which are running, whose flows are very small. Okay, so filter equal to fl less than, which are the most least used, so there is none. Yeah, so these are my application with very less data: Acronic, Cyrillic, and we start with A. So F, yeah, these are start with F. So that way you can filter and run everything via this CLI. So yeah, so we can test it on some big database, and if with more fields implemented, and if this work fine, we can integrate the same with our current topic flow without implementing a new GUI as we thought earlier. So yeah, that's it for this video. So yeah, just right now this is a conversion of 73 gig of flows. The flows are converted into conversation and protocols and these fields. So on query you don't do it on 73G. It is a converted database. So we need to implement more fields to get the actual stats, but yeah, this gives a bold figure, like yeah. So top queries are actually optimized because we are pre-processing all the data, so we don't wait for query and then combine it. So our database are combined at the when the data is fed into the database. So yeah, that's it for this video.